IR execution artifact. Recent file cache.bcf. To address compatibility issues with operating system updates and upgrades, there is a service called Application Experience Lookup that handles application compatibility cache requests for applications when it starts. The service monitors and processes compatibility each time an application is executed. Information is written about the application that has compatibility issues in the recent file cache.bcf file. The recent file cache.bcf file is used to temporarily store the program path when a process is created. In other words, recent file cache.bcf simply creates an absolute path to an executable in Unicode format. Recent file cache.bcf does not store all executed process information, but temporarily creates another executable file, such as a dropper, from another executable file or from another volume, system, or program that has been downloaded and copied from the Internet. However, the problem is that the information is temporary, even though it is very useful for identifying malicious code execution traces. Windows has two work schedules associated with Application Experience, AE, by default. One is AIT Agent, and the other is Program Date Updater. Of these, recent file cache.bcf is related to Program Date Updater, and each time the corresponding operation is performed, the recent file cache.bcf file is initialized. The AE-related tasks are activated by default and are executed every day, so the files are initialized once a day. If possible, analyzing the impact of the work and then increasing the work execution cycle could be one of the preparations for an intrusion. The following shows the contents of the recent file cache.bcf file using a tool called bintext. You can see that the absolute path of the executable file is listed as shown in the figure. amcache.hve. The amcache.hve file is replaced with the registry Hive file by moving the recent file cache.bcf file from Windows 7 to Windows 8. As mentioned earlier, the amcache.hve file internally has the form of a registry hive, and the file structure consists of the file key, the generic key, the orphan key, and the programs key under the root key. The generic and orphan keys store GUID or file ID related information. The programs key stores information such as installed application name and version. The file key stores a lot of information such as initial execution time related to the application program. The characteristics of the amcache file are related to the Program Compatibility Assistant. PCA enables legacy applications to run on Windows Vista and later operating systems despite compatibility issues. The PCA detects application installation failures caused by inconsistencies during version checking and attempts to recover from failure by applying appropriate compatibility settings to the application in question. The PCA manages the database for programs with known compatibility problems and notifies the user of potential problems at program startup. That is, the PCA checks whether the application program is operating normally on the operating system, and if the application program does not operate normally, the problem is solved in the compatibility database. The size of the amcache file is initially set to 256 kilobytes, and when the application is executed, related information is accumulated in the amcache file. When the application is executed, the file reference key of the program is generated and related information is recorded in the amcache file. If the file reference key is not created, the relevant information is not recorded in amcache. In other words, application-related information is written to the amcache file only on the first execution and not after the second execution. However, even if it is the same program, when the installation and execution path and the program name are different, the file reference key is newly generated and related information is accumulated and recorded in the AMCache file. The AMCache file is in the registry Hive structure, and you can see the keys File, Generic, Orphan, and Program under the root key. File keys are grouped into volume GUIDs. The GUIDs identified here are identically identifiable in mounted devices under System and Mount Point 2 and NTUser.dat. You can see the time information related to the execution program for each volume in the corresponding key. The generic key and the orphan key provide information about the GUID and file ID. The program key contains information about the installed program. The following is a summary of the information that can be found in the key that makes up the AMCache registry. The following table summarizes the values for distinguishing file key values. The volume GUID under the file key contains a file reference key. The file reference key is a combination of numbers and contains a numeric value. For example, a value of 15 is a value indicating the entire path of a file, and the value can be used to identify the entire path. Like the file key, the program key also contains the value, which is a set of numbers. There is a slight difference from the file key. As mentioned earlier, the nature of the AMCache file allows you to check the application's initial execution time. In particular, in the case of an application program installed in the control panel, since a plurality of executable files are packaged, the initial execution time for each executable file can be confirmed. For example, BCWipe program can check initial setup time and creation time with bcwipesetup.exe. bcwipe.exe can check the first execution time, and bcuninstall.exe can check the delete time. In other words, you can check the creation, installation, and deletion time of application program through AMCache file. In addition, the anti-forensic program and the portable program execution trace recorded in the entire path can be confirmed. In addition to this, it is possible to trace malicious code execution and anti-forensic tool usage through AMCache. You can track devices connected to the system through volume GUIDs created in file. As mentioned earlier, the corresponding values are the same in mounted devices under System and Mount Point 2 in NTUser.dat. Registry. Windows Registry is a database containing settings and selections for Microsoft Windows 32/64-bit and Windows Mobile operating systems. It contains all hardware, operating system software, most non-operating system software, information and settings are included. When a user changes control panel settings, file associations, system policies, or installed software, the changes are reflected in the registry and stored. The registry also exposes Windows in the kernel's operating system, exposing runtime information such as performance counters and the hardware it is currently using. Previously, INI files were used for each program to contain configuration settings for Windows programs. These files were not easy to find by spreading them around the system, so the Windows Registry was introduced. Such a registry is an essential element of Windows system analysis, and it can check operating system information, user account information, system information, application execution trace, and recently accessed documents. You can also analyze Autorun's malware detection, storage connection traces, and more. The Windows Registry stores settings in a physical file called a Hive. The key values are stored in a logical structure, and the Hive file is managed by the kernel from the boot process. There are various kinds of Hive files such as SAM, security, system, software, default, ntuser.dat, usrclass.dat, and components. The following shows the data structure of Registry Editor provided by Windows. In the window to the left, you can see the registry key tree. Here it is possible to check the entire key of the registry in a tree structure. In the right window, you can see the setting value for the key selected on the left. You can check the value name, data type, and data for each setting. You can see the keys that are identified in the left pane of the Registry Editor, starting with H key, which is called root key. In addition to the 5 root keys identified in the Registry Editor, a root key named HKey_performance_data is configured. There are 6 types of root keys, and the data sets stored in each root key are different. Refer to the training data for explanation of the data set stored in each root key. It consists of 2 master keys and 3 derived keys. Master keys are HKey_local_machine and hey_users, and the rest are HKey_current_config, HKey_classes_root, and HKey_current_user. The master key is stored in the system as a file named Hive. Derived key is derived from the master key to construct the key, as the name implies. In other words, the derived key can be checked only in live mode. However, hardware in HKey_local_machine is not saved as a Hive file. The table shows the Hive file path of the master key mentioned above. There is a folder named regback in the path where Registry Hive file is saved. There is a Registry Hive backup file in that folder. You can also see the registry log file with the extension log. The Windows system consists of a backup file and a log file for the registry. These files have the same structure as the Registry Hive. In other words, it is possible to check the registry information at a certain point through the backup file or the log file. After Windows Vista, Volume Shadow Copy is used instead of Restore Point. It is possible to analyze a Registry Hive file stored at a specific point in time through Volume Shadow Copy, as it was possible to extract the Registry Hive file using the past restore point. This way, the registry stored at a specific point in time can be compared with the registry stored in the current system to identify the difference and reconstitute the events that occurred in the system. Among the methods of analyzing user behavior through the registry, there is a way to identify the applications that the user has executed. Method is to use User Assist. User Assist contains a list of program names that have been executed on the system, as well as the number of executions and the most recent execution time. This information can be used to track user application traces. User Assist is ROT-13 encoded and is separated into Application Run History and Shortcut File Run History. Through this, it is possible to check information such as the type of application program, the last execution time, and the execution frequency. The CID size MRU in the registry allows you to check the name of the application that was recently launched. The CID size MRU key is a key that stores information about the dialog box size of a user-defined application and has been added since Windows Vista. When a dialog box is activated in a specific application, it is written to CID size MRU. With this information, you can check the application execution trace through the information recorded in the key. You can also check the name of the recently executed application in the first folder key in the same path as the CID size MRU mentioned above. The first folder key creates the path and file name where the application is stored. The last visited MRU allows you to view recently executed executables, folder paths, and folder paths via dialogues. If you have used the Windows Run window, you have already confirmed that the Run window supports auto-completion of your input values. The key to support such auto-completion is the Run MRU key. The Run MRU key is a registry key that records the execution command entered by the user. From the analytical point of view, Run MRU can be used to identify commands entered by the user and analyze user behavior. MUI stands for Multilingual User Interface. In other words, MUI cache is a key that caches program names to support multiple languages. When a new application is executed, the program name is automatically extracted from the resource area and stored in the MUI cache key. By talking back and seeing what's written on the key, you can see the application execution trace. There are a variety of registry types that allow you to see the list of services running on Windows systems. Among them, there is a registry key starting with legacy_, which is stored under enum and root. The key is generated by the operating system when the service is executed, not generated directly by malicious code. This allows you to see the execution trace of malicious code running as a Windows service. Additionally, the last modification time of the key is the time when the malicious service was first run. Microsoft, the tracing key, is the key that stores the tracking information that the routing and remote access service records. Trace information is stored to troubleshoot complex network problems. Some malicious codes include network functionality. In such a case, you can see the execution trace of malicious code that uses the network through the key. If you do not select the environment that you want to operate correctly, or if you cannot implement all the available environments, compatibility problems will arise. The application compatibility cache is used in this case. It is easy to talk about, and it is a function to provide backward compatibility according to the update of operating system. Compatibility issues are related to the APIs used by applications. One of the biggest concerns for application developers every time the operating system is upgraded is the changed API. This is because existing APIs disappear and new APIs are created. Even if the existing API disappears, there is an alternative API to replace it. However, developers do not need to modify all APIs. The reason for this is that SDB has recorded all relevant information for each application. And the shim engine hooks API calls based on this information and hooks them to the replacement API. The compatibility function of running an application in the same role is also called. When you run the application, the create process internal W function of kernel32.dll is started, and the function internally calls the basep check bad app export function. This function checks the cache data before searching the database information with a function that performs compatibility check. If you do not find any application compatibility problems in the cache, check the database. This compatibility cache stores information about applications that have encountered compatibility problems on their systems. As with the role of regular caches, if a program has already been executed, it will be processed quickly using the compatibility cache before looking at the database. The above compatibility cache information is stored in the registry, and the path of the registry key is system, control set 00 pound key, control, session manager, and app compat cache. You can see information about the compatibility cache in that path. The structure of the compatibility cache shows the path of the application, the file size, the last modification time of the file, and the last update time. Execution information of the application is usually found by checking the prefetch information, but since the maximum number of prefetch is limited to 128, it is not suitable for checking the old execution trace. Also, recent malware containing anti-forensic techniques tend to delete known artifacts such as prefetch files. In this situation, the compatibility cache information can be very useful. The following is a screenshot of the compatibility cache analysis tool named Shim Cache Parser. You can download it from github.com/mandiant/shimcacheparser. The compatibility solution is defined in the compatibility database, which is located in the C/Windows/AppPatch/folder. The database contains solutions for about 5,000 applications. Each time a compatibility problem is expected, the database is consulted to follow a defined solution. The database is updated with the hotfix by referring to the information sent by the user to Microsoft. Most of the programs developed in Korea are also included in the database. However, if the database does not find a suitable solution, the Program Compatibility Manager prompts the user for confirmation via the dialog box. At this time, if the user selects this program is installed properly in the active dialog box, this content is managed separately from the persisted key in the registry. If there is a compatibility problem with information in the database, the contents are stored in the compatibility cache registry value. The saved compatibility cache is referenced before the database when the user reruns the application. Also, as a solution to the compatibility problem, if the compatibility mode, settings, permission level, etc. are set up as dialog boxes, this information is stored in the following registry. It is stored in HKCU or HKLM, depending on whether it is applied only to a specific user or system-wide. The following is a list of registry-related analysis tools available on the Internet. Each tool can be downloaded for free from the URL. Windows Error Reporting. Windows Error Report, WER, is a feature added since Windows XP that collects and reports debugging information related to errors when a hardware or software error occurs in the operating system. If you've been using Windows, you've probably seen a dialog box asking if you want to send related information to Microsoft every time an error occurs since XP. Here is the WER dialog box that appears in Windows 8. WER information sent by users is properly categorized and stored on Microsoft servers, and Microsoft partners, ISVs, IHVs, OEMs, etc., can review the information. In the past, you could see WER information on WinQual, Windows Quality Online Services site, but recently, this information was integrated into the Windows Developer Center. Serious or frequently encountered errors are often reflected in hotfixes. WER operates as a service named Windows Error Reporting Service, and the settings for that service can be set in the Control Panel, Action Center, Problem Reporting Settings path. The following is the contents of the path where the WER log is stored. Critical and non-critical folders are classified according to importance of error. In each folder, a textual log is stored as a file named report.wer. The following is a Windows Error Report sample file. You can check event time, upload time, file path, and file name through WER file. In Windows 7, logs are recorded for each service in addition to the default event, system, security, and application logs. Since WER also operates as a service, the path for leaving an event log is as follows. As a result, if the event log has not been initialized or deleted, you can also see the error status through the event log.